Hi, so today's lesson is going to focus on igneous rocks. So yesterday we went over what rocks are and an introduction to the rock cycle, and today we're going to focus on one specific type of rocks, which, as I said, are igneous rocks. Igneous rocks form when magma from the Earth's interior cools and solidifies.
The Earth's crust is made up of different types of rocks. The rocks which make up the maximum volume of the Earth's crust are called igneous rocks. The word igneous has been derived from the Latin word ignis, which means fire. These rocks are associated with volcanic eruptions. Let's study more about igneous rocks and how they are formed.
As this diagram shows, molten rock, or rock that's heated into a liquid form, is known as magma when it's below Earth's surface. Once this molten rock mixture comes out of a volcano and reaches the surface, it is then known as lava. This lava on Earth's surface cools quickly and quickly solidifies.
The cooling and the solidification of lava at the Earth's surface result in the formation of extrusive igneous rocks, which are also known as volcanic rocks. Due to rapid cooling, their crystals are fine-grained. However, some of the magma can't come out and settles inside the surface. The magma cools slowly beneath the Earth's surface as it is completely surrounded by the soil and rock present there. The cooling and the solidification of magma at a depth within the Earth's crust result in the formation of rocks having large crystals, known as intrusive igneous rocks. So we have learned that igneous rocks are of two types: extrusive igneous rocks and intrusive igneous rocks.
So this fact that igneous rocks can be either intrusive or extrusive can lead us to figure out some properties for these rocks. For example, extrusive rocks, they cool very quickly when they hit Earth's atmosphere, so they don't have time to develop minerals over time, and they become more fine like this, and you can't see any coarse grains or any large chunks of minerals, or they can even be as glassy as obsidian, which is this very shiny, looks all the same texture, same color, and there's no visible grains. As opposed to the intrusive rocks, which form underneath Earth's surface, and they cool very slowly because they're not exposed to Earth's air. So they form into things like this granite, where you can see massive grains. You can see feldspar, quartz, and mica in here. So why do the slow-cooling intrusive rocks beneath Earth's surface have formations of large rock crystals? But the fast-cooling extrusive rocks on Earth's surface have very fine or small grain. It's like if you were in class and your teacher told you had a very short time, say 2 seconds, to form a group with your friends to sit with for the rest of the year. After 2 seconds, you would barely have enough time to move, let alone form a group. So most, if not everyone, would be stuck by themselves without a group. Now if your teacher gave you a long time, say 10 minutes, you would have plenty of time to get up and move around and form a group of your friends that you want to sit with. This process happens with rocks, except on a larger time scale, and the process is still the same. The extrusive rocks that cool and solidify very rapidly have no opportunity to find and clump similar minerals together in order to form large crystals. so they are stuck with a very fine-grained makeup. The intrusive rocks that get much longer to cool and solidify have all the time in the world to pair minerals together to form bigger crystals and therefore have bigger grains.
Now, if you remember back to the beginning of the geology lesson, we talked a little bit about the structure of the Earth. So now we're going to discuss oceanic and continental crust. Continental crust is thicker and less dense. Oceanic crust, as you may remember, is thinner but more dense. So now we're going to talk about the rocks that make up each of these two different types of crust. So continental crust is the crust that makes up all the landforms and continents on Earth. So continental crust is made up of sialic rocks, which are lighter in color, and they are made of aluminum, oxygen, potassium, sodium, and silicon-rich rocks. This sialic crust also occurs due to a remelt of the continental crust. The word parts Si come from silicon and Al is aluminum, so you can remember that word that way. Mafic rocks are darker in color and they are calcium, iron, sodium, and magnesium rich, but they are poor in silicon. So these rocks originate from the mantle, and they also are what make up the oceanic crust. So mafic, the M comes from magnesium and the F comes from iron. Common examples of this include biotite mica and feldspars, also basalt and gabbro.
So as we said, sialic is going to be the lighter rocks and mafic is going to be the darker rocks. This has to do with the silica content present, and sialic rocks will have more silica in them, as you can see from this graphic we'll throw up on screen. This shows that any rock in between sialic and mafic is classified as intermediate, and it just means the silica content is between those two classifications. And there's also a category called ultramafic.
So now we're going to discuss a little bit about the textures of rocks. So this granite block here is a good example of a coarse rock. See all the different quartz and feldspar and mica spots that make it up? And then another texture of rocks is glassy, like this obsidian here. Another texture is fine, where you don't see any of the mineral parts that make up the rock. And then the last texture is called frothy. This is a result of frothy lava. As it cools, it leaves behind these gas bubbles. And this is scoria, and another common example of a frothy rock is pumice.
Okay, so putting all this together, we can look at this chart. It has intrusive and coarse all the way down to extrusive and fine. That's the grain it's talking about. And then going across the top, we have sialic all the way to mafic with the intermediate in between. And we have some real life examples here of a sialic intrusive rock, just granite. And you can see it has a ton of the silica in it, so it's very white. And as you move to the intermediate rock, you can see that it has a little bit less white in it, and it's getting a lot more darker, and that's diorite. Then as we go to gabbro, you can see it's very dark, which is a key identifying feature of mafic rock. And then as you're going down to the more fine grain rocks, you get to the extrusive side. And this is the sialic, this is the rhyolite. And as we get to intermediate, we get to an andesite, and you can see again it's getting more darker. There's more dark spots on it. And then finally you get all the way to the mafic side, which is basalt, and you can see it's very dark, but it still has the characteristic fine grains of extrusive rocks. And then just to show some examples of the other properties we went over, you can see we have pumice here and scoria, and these have a very frothy texture to them. You can probably see the bubbles that have built in here as they cooled. And then the final one is our obsidian with the classic glassy look, and that we call it a glassy texture.